cube root of a number x is a number whose cube is x. So for example, when we have the expression the cube root of 8, we're thinking what number times itself again would result in 8. And the answer is 2, because 2 times 2 times 2 would be 8. And if we calculate the cube root of negative 8, negative 2 times negative 2 times negative 2 is negative 8. So the cube root of negative 8 is negative 2. And here you'll notice a difference between these problems and the square root problems we were looking at before. When you have a positive number under a square root, you get a positive answer. When you have a negative number under a square root, you ended up with not a real number for your answer. In general, even index roots, by which I mean square roots, fourth roots, sixth roots, and so on, even index roots of positive numbers are positive. But even index roots of negative numbers are not a real number. Now, odd index roots, by which we mean things like cube roots or fifth roots or seventh roots and so on, odd index roots of positive numbers are positive. Odd index roots of negative numbers are negative. Keeping these things in mind, if we look at an expression like the fourth root of 16, we're thinking what number, when we multiply 4 of the same number together, would result in 16. 2 times 2 times 2 times 2 is 16, so the fourth root of 16 is 2. For the next problem, the fifth root of negative 32. I have an odd root of a negative number. I know I'm going to get a negative answer. And the number that would work in this case would be a negative 2, because if I multiply negative 2 times negative 2 times negative 2 times negative 2 times negative 2, the result would be negative 32. And having completed that problem, the next problem should be pretty short. The fifth root of positive 32 would then be just positive 2. Now make sure you understand the difference between the next two problems. If we have negative square root of 36, here, when there's a negative at the front of the problem, stick a negative at the front of your answer. And the square root of 36 is 6, so negative 6 is our answer in this case. But when we see the fourth root of negative 16, here we have an even index root of a negative number. We can stop right there and say not a real number. If we're looking at the fourth root of 81x to the 8th, the fourth root of 81, 3 times 3 times 3 times 3 is 81, so the fourth root of 81 is 3. For the fourth root of x to the 8th, we divide our exponent by 4 to see what our new exponent would be, and we have x squared. So 3x squared is the solution to that problem. If you would like to try the next problems on your own, pause the video now and resume when you're ready to see the solution. For the cube root of negative 64x to the 12th, we think of the number and the variable part separately. The cube root of negative 64 is negative 4. For the cube root of x to the 12th, we divide our original exponent by 3, and our final answer is negative 4x to the 4th. The next problem, we have a negative at the front of the root, so we stick a negative at the front of our answer. For the fifth root of x to the 5th, we divide our original exponent by 5, and we get that our new exponent would be 1. It's not wrong if you put negative x to the first, but normally people don't bother writing a 1 exponent, and it would normally be written just as negative x. When we see the fourth root of negative 81x to the 12th, here we have it. If we're assuming in the directions that our variable is a positive number, then the expression underneath the root is negative. and it's not 0. So if that variable is positive, we have a negative under a fourth root, we can stop right here and say that this is not a real number.